Imagine standing in one of the most beautiful places on Earth. Crystal clear rivers, towering mountains, ancient forests, herds of bison roaming across endless valleys. Steam rises gently from colorful hot springs. Tourists pause to admire the breathtaking scenery. It feels peaceful, timeless, safe, but beneath your feet, something unimaginable is happening. Hidden deep underground lies one of the largest volcanic systems on Earth, a sleeping giant, one that has shaped continents, changed the climate, and continues to remind scientists that our planet is very much alive. Welcome to Yellowstone. Every year, millions of visitors travel to Yellowstone National Park. Established in 1872, it became the world's first national park. People come to witness erupting geysers, brilliant hot springs, powerful waterfalls, and some of North America's most iconic wildlife. But Yellowstone is far more than a beautiful landscape. It is one of the most active geological regions on Earth. Everything you see has been shaped by immense forces hidden far below the surface. Walk through Yellowstone, and the Earth seems to breathe. Steam escapes from cracks in the ground. Pools of vividly colored water bubble continuously. Mud boils. Geysers erupt with astonishing precision. These are not isolated wonders. They are connected. Each feature is part of an enormous geothermal system powered by heat rising from deep within the Earth. Yellowstone is alive, not with lava flowing across the surface, but with energy constantly moving beneath it. Most volcanoes announce themselves with towering mountains. Yellowstone does not. There is no single volcanic cone dominating the skyline. Instead, the volcano stretches beneath much of the park. Its vast magma system lies kilometers below the surface, so immense that early explorers had no idea they were standing on top of it. Only modern geology revealed the astonishing truth. Yellowstone isn't just a volcano. It is a supervolcano. Ironically, the same underground heat that created Yellowstone's volcanic past also created its breathtaking beauty. Minerals dissolved in hot water paint springs in brilliant shades of blue, green, orange, and gold. Towering geysers launch boiling water into the sky. Hot springs shimmer like jewels. Without the heat below, none of this extraordinary landscape would exist. Yellowstone is not only a geological wonder, it is one of the world's greatest wildlife sanctuaries. Bison graze across open valleys. Wolves hunt through forests. Grizzly bears roam mountain slopes. Elk migrate with the seasons. Here, life is adapted to thrive in a landscape shaped by fire, ice, and time. For decades, one question has captured the world's imagination. Could Yellowstone erupt again? The answer is more complex than headlines often suggest. Scientists monitor the park around the clock. Thousands of tiny earthquakes, ground movements measured in millimeters, changes in geysers, gas emissions. Every signal helps researchers better understand this remarkable volcanic system. The story of Yellowstone is not one of panic. It is one of science. Millions of years ago, Yellowstone unleashed eruptions so powerful, they reshaped landscapes across North America. Ash darkened skies. Lava transformed the land. The world was never the same. In the next chapter, we'll travel back through deep time to witness the three colossal eruptions that made Yellowstone one of the most extraordinary places on Earth. Long before humans walked the Earth, long before the Rocky Mountains looked as they do today, a force beyond imagination erupted from beneath the land. Not once, not twice, but 3 separate times. Each eruption was so powerful that it permanently reshaped the landscape of North America. Ash traveled thousands of kilometers. Entire ecosystems disappeared. The climate changed, and a volcanic system unlike any other was born. This is the astonishing story of the eruptions that created Yellowstone. Travel back more than 16 million years. The western United States looked very different. Volcanoes were already active across the region. Deep beneath the Earth's crust, a powerful plume of unusually hot rock was slowly rising from the mantle. As the North American tectonic plate drifted southwest over this hotspot, a chain of enormous volcanic eruptions began to leave its mark across the landscape. That journey would eventually create Yellowstone. Around 2.1 million years ago, Yellowstone experienced its first known supereruption, known as the Huckleberry Ridge eruption. It was one of the largest volcanic events ever identified on Earth. Thousands of cubic kilometers of volcanic material were expelled. The explosion emptied enormous underground magma chambers. Without support beneath the surface, the ground collapsed inward. This collapse formed the first giant volcanic basin, known as a caldera. The Yellowstone landscape had changed forever. The eruption did not affect only Yellowstone. Powerful winds carried volcanic ash across much of North America. Layers of ash settled hundreds, and in some places, thousands of kilometers from the eruption. Today, geologists continue to find evidence of these ancient ash deposits in multiple states. These layers act as time markers, helping scientists reconstruct one of Earth's most extraordinary geological events. Roughly 1.3 million years ago, the Yellowstone hotspot erupted again. This event, known as the Mesa Falls eruption, was smaller than the first, but by any ordinary standard, it was still colossal. Once again, the landscape was transformed. New lava fields spread across the region. Fresh volcanic deposits reshaped valleys and mountains. The Earth's surface remained restless. Then, about 631,000 years ago, Yellowstone erupted for a third major time, the Lava Creek eruption. This eruption created much of the modern Yellowstone caldera visible today. Pyroclastic flows race across the landscape. Ash rose high into the atmosphere. When the eruption ended, the surface collapsed once again. The immense basin beneath today's Yellowstone National Park had taken shape. Much of the scenery visitors admire today owes its existence to this ancient event. Over hundreds of thousands of years, rain, snow, rivers, plants, and wildlife gradually transformed this volcanic landscape. The scars left by ancient eruptions became forests. Collapsed craters filled with life. Geothermal heat continued rising toward the surface, creating the famous geysers, hot springs, mud pots, and fumaroles that define Yellowstone today. One of Earth's most destructive forces had created one of its most beautiful places. Although the great super eruptions ended long ago, the hotspot never disappeared. Deep beneath Yellowstone, heat continues to rise from the Earth's mantle. That heat powers the park's geothermal features. It also reminds scientists that Yellowstone remains an active volcanic system, not because an eruption is expected soon, but because the Earth beneath the park is still alive. Understanding that activity is one of modern geology's greatest challenges. Yellowstone's history is written in layers of ash, solidified lava, and collapsed volcanic basins. It is a reminder that landscapes we consider permanent can be transformed by forces operating far beneath our feet. Millions of years later, the evidence still surrounds us, waiting to be read. If Yellowstone's eruptions were powerful enough to reshape a continent, then what lies beneath the park today? How much molten rock still exists? How do scientists know what's happening kilometers below the surface? In the next chapter, we'll descend deep beneath Yellowstone to explore its hidden magma chambers and uncover the extraordinary technology revealing one of Earth's greatest geological mysteries. Far below the forests, the rivers, and the millions of visitors who walk its trails every year, lies one of the most extraordinary geological structures on Earth. It cannot be seen from the surface. It cannot be photographed directly. Yet it is there, a vast underground system of molten and partially molten rock, stretching for dozens of kilometers beneath the park. For decades, scientists wondered what truly existed below Yellowstone. Today, thanks to remarkable advances in technology, they are finally beginning to see the hidden monster beneath their feet. Unlike mountains or rivers, the Earth's interior cannot simply be observed. Scientists must rely on indirect clues: tiny earthquakes, ground vibrations, gravity measurements, electrical conductivity, and satellite observations. Every piece of data acts like another fragment of a giant puzzle. Together, they allow researchers to build an increasingly detailed picture of what lies deep underground. One of the most important discoveries came through seismic imaging. Researchers found a large reservoir of partially molten rock several kilometers beneath the surface. Despite its dramatic reputation, this reservoir is not a giant underground lake of liquid lava. Instead, it consists mostly of solid rock, with pockets of molten material distributed throughout. Understanding this distinction is crucial. A partially molten system behaves very differently from a chamber filled entirely with liquid magma. As technology improved, scientists discovered something even more remarkable. Beneath the upper reservoir, they identified a much larger region of hot rock extending deeper into the Earth's crust. And deeper still, a mantle hotspot continues supplying heat from below. This enormous system acts as Yellowstone's energy source. It has remained active for millions of years, slowly transferring heat upward through the crust. But how do scientists see underground? The answer lies in earthquakes. When seismic waves travel through the Earth, they move at different speeds depending on the rocks they pass through. Solid rock, hot rock, molten material. Each affects the waves differently. By analyzing thousands of seismic recordings, scientists create detailed three-dimensional images of Yellowstone's interior. It's similar to how doctors use CT scans to see inside the human body, only on a planetary scale. Yellowstone is constantly changing. Some areas slowly rise, others gradually sink. These movements are usually measured in centimeters rather than meters. Scientists attribute many of these changes to the movement of underground fluids and heat within the volcanic system. Highly sensitive GPS instruments, satellite radar, and ground-based monitoring stations track these subtle changes continuously. The Earth beneath Yellowstone is never completely still. The heat rising from below creates one of the greatest collections of geothermal features anywhere on Earth. More than half of the world's active geysers are found in Yellowstone. Water seeps underground. It is heated by hot rocks. Pressure builds. Then, without warning, a geyser erupts. Hot springs shimmer with brilliant colors. Mud pots bubble endlessly. Steam escapes through vents across the landscape. Every feature is a reminder that deep beneath the park, the Earth's internal heat is still at work. Today, Yellowstone is among the most closely monitored volcanic systems on Earth. Teams of geologists, geophysicists, hydrologists, and other researchers continuously study its activity. Thousands of earthquakes are detected each year. Most are so small, people never feel them. Each one provides valuable information about the movement of rock and fluids beneath the park. The goal is not to predict an exact eruption date. It is to understand how this remarkable volcanic system behaves over time. The Yellowstone supervolcano is not simply a mountain. It is an immense geological engine, hidden beneath forests, lakes, and wildlife. Its slow movements remind us that Earth is not a static planet. It is constantly evolving, even when those changes are invisible to us. For generations, the words Yellowstone supervolcano have sparked fear around the world. Movies have imagined global catastrophe. Headlines have predicted disaster. But how much of that is actually true? Can Yellowstone really erupt tomorrow? Or is the reality very different from the myths? In the next chapter, we'll separate science from sensationalism and answer one of the most searched questions on Earth. Could Yellowstone erupt again? Few places on Earth inspire as much fascination, or as much fear, as Yellowstone. Every year, headlines appear claiming, the supervolcano is about to erupt. Movies imagine as covering continents. Social media predicts the end of civilization. Millions of people ask the same question. Is Yellowstone about to explode? The answer may surprise you, because the real story is far more fascinating than the myths. The word supervolcano immediately captures attention. Unlike ordinary volcanoes, the supervolcano has the potential to produce eruptions of extraordinary size. That possibility has inspired countless documentaries, Hollywood films, television specials, and online speculation. But fear often grows faster than facts. Scientists emphasize that understanding Yellowstone requires evidence, not sensational headlines. The simple answer is, yes, Yellowstone is an active volcanic system. That does not mean an eruption is imminent. Active volcanoes can remain quiet for extremely long periods while continuing to produce heat, earthquakes, and geothermal activity. Yellowstone's famous geysers, hot springs, mud pots, and steam vents exist because heat continues rising from deep underground. The system is alive, but being active is not the same as preparing for a catastrophic eruption. Every year, thousands of small earthquakes occur beneath Yellowstone. Most are far too weak for people to notice. Many happen in clusters known as earthquake swarms. Scientists also observe gradual changes in ground elevation. Some areas slowly rise, others slowly sink. These movements are common within geothermal regions and often reflect the circulation of underground fluids and changes in pressure. By themselves, they do not indicate that a major eruption is about to occur. If Yellowstone were moving toward a major eruption, scientists would expect to observe multiple significant changes occurring together. These could include a substantial increase in earthquake activity, noticeable and sustained ground deformation, significant changes in gas emissions, alterations in geothermal behavior across the park. Yellowstone is monitored continuously using satellites, GPS stations, seismic networks, gas sensors, and field observations. At present, researchers have not observed evidence indicating that a super eruption is imminent. The park continues to behave as an active geothermal system. Protecting Yellowstone means understanding it. The Yellowstone Volcano Observatory brings together experts who study earthquakes, ground movement, gas emissions, water chemistry, and geothermal activity. Their findings are shared publicly. Every new measurement improves our understanding of how the volcanic system behaves. Rather than waiting for disaster, scientists watch the volcano every single day. Knowledge is the strongest tool they have. When people hear Yellowstone eruption, they often imagine the largest possible event. But geology tells a different story. Throughout Yellowstone's long history, smaller lava eruptions have occurred far more frequently than super eruptions. If volcanic activity were ever to return, a relatively small lava flow would be considered much more likely than a continent-scale eruption. Such an event would still be significant, but it would be vastly different from the catastrophic scenarios often portrayed in popular culture. Yellowstone deserves respect, not panic. It reminds us that Earth is dynamic. Mountains rise, continents move, volcanoes evolve. Scientists continue studying Yellowstone because every discovery improves our understanding of the planet beneath our feet. Its story is not one of inevitable catastrophe. It is a story of patience, science, and the immense forces that have shaped our world for millions of years. The greatest lesson Yellowstone teaches us is that nature does not operate according to rumors. It follows the laws of geology, and those laws can only be understood through careful observation, research, and time. If a super eruption is unlikely in the near future, then why do scientists continue monitoring Yellowstone so closely? Because even without a super eruption, the park is constantly changing. New geysers appear, old ones fall silent. Earthquakes reshape the underground plumbing. The landscape is evolving every single day. In the next chapter, we'll explore Yellowstone's extraordinary geothermal wonders and discover why it contains more than half of all the active geysers on Earth. Imagine standing on ground so hot that rainwater falling from the sky could disappear deep underground, be heated to nearly boiling, and then explode back into the air, higher than a 10-story building. Now imagine thousands of places where this happens. Welcome to the greatest geothermal wonderland on Earth, a place where the planet itself appears to breathe. Yellowstone contains the largest concentration of geothermal features anywhere on Earth. More than 10,000 geothermal wonders are scattered across the park. They include geysers, hot springs, mud pots, steam vents, and bubbling pools. Together, they represent one of the most active hydrothermal systems ever discovered. Every single feature exists because of the enormous heat hidden beneath Yellowstone. A geyser begins with something surprisingly ordinary: rain and snow. Water slowly seeps through cracks in the ground. It travels deeper and deeper until it reaches rocks heated by Yellowstone's underground magma system. The water becomes extremely hot, but because of the immense pressure underground, it doesn't immediately boil. Instead, pressure continues to build until, without warning, the water flashes into steam. The expanding steam forces everything above it skyward. The result, a spectacular eruption, nature's own pressure cooker. No geothermal feature is more famous than Old Faithful, discovered during the 19th century. It earned its name because its eruptions occur at relatively predictable intervals. Unlike many geysers, Old Faithful follows a rhythm. Its eruptions can reach heights exceeding 50 meters. Each performance sends thousands of liters of boiling water into the sky. Visitors gather patiently, knowing they are about to witness one of Earth's most extraordinary natural spectacles. Perhaps Yellowstone's most breathtaking sight is the Grand Prismatic Spring. At first glance, its brilliant rings of blue, green, yellow, orange, and red look almost unreal, but the colors are not created by minerals alone. Tiny heat-loving microorganisms, known as thermophiles, live in different temperature zones around the spring. Each community produces its own pigments. Together, they transform boiling water into one of nature's greatest works of art. For many years, scientists believed nothing could survive in boiling water. Yellowstone proved them wrong. Specialized microorganisms thrive in temperatures that would kill most forms of life. These extremophiles have transformed biology. Some of their unique enzymes became essential tools in modern DNA research and medical science. What began as a study of strange bacteria in hot springs ultimately changed laboratories around the world. Sometimes, the smallest discoveries have the greatest impact. Not every geothermal feature erupts. Some simply bubble. Mud pots form where acidic water breaks down, surrounding rock into fine clay. Underground heat warms a mixture. Gas escapes through the mud, creating thick bubbles that burst continuously. The sound resembles boiling porridge, or a giant pot simmering beneath the earth. It is another reminder that Yellowstone is always changing, even when nothing dramatic appears to happen. Some places contain very little underground water. Instead, steam escapes directly through narrow openings. These features are called fumaroles. Temperatures around them can become extremely dangerous, yet they offer scientists valuable clues. By studying the gases released, researchers gain insight into the hidden volcanic system beneath Yellowstone. Every plume of steam carries information from deep inside the earth. Yellowstone is never truly the same. Earthquakes can redirect underground water. New hot springs appear. Existing geysers become more active or fall silent. Entire geothermal areas slowly evolve over decades. Visitors may return years later, only to discover that the landscape has changed. The park is not frozen in time. It is one of Earth's most dynamic environments. Every geyser, every hot spring, every cloud of steam is part of an immense underground system that has been active for hundreds of thousands of years. Yellowstone reminds us that our planet is alive. Its heartbeat may be slow, but it never stops. Yet Yellowstone's greatest wonders are not found beneath the ground. They walk across its valleys. They roam its forests. They hunt along its rivers. Bison, wolves, grizzly bears, elk. This volcanic landscape has become one of the greatest wildlife sanctuaries on Earth. In the next chapter, we'll discover how life has flourished on top of one of the most active volcanic systems on the planet. At first glance, Yellowstone appears to belong to fire, boiling springs, exploding geysers, hidden magma. But look closer, and another story begins to unfold. One of survival, one of balance, one of life adapting to one of the most dynamic landscapes on Earth. Here, animals do not merely survive. They thrive on top of a living volcano. No animal symbolizes Yellowstone more than the American bison, weighing up to 900 kilograms. These giants have roamed North America for thousands of years. Once, tens of millions covered the continent. By the late 19th century, their numbers had fallen dramatically. Yellowstone became one of the last places where wild bison survived. Today, the park protects one of the oldest continuously wild bison populations on Earth. Watching hundreds of these ancient animals move across the valleys feels like stepping back into prehistoric America. Sometimes, changing just one piece of nature changes everything. For decades, wolves were absent from Yellowstone. Without their natural predators, elk populations expanded. Young trees struggled to grow. Riverbanks changed. Then, in 1995, gray wolves returned to the park. What followed became one of the world's most famous examples of ecosystem recovery. Scientists observed changes throughout the landscape. Elk altered where they grazed. Willows and aspens recovered in many areas. Beavers found more food. Birds returned. The wolves did more than hunt. They helped reshape an ecosystem. The grizzly bear is one of Yellowstone's most iconic residents. Powerful, intelligent, and endlessly adaptable, a grizzly's diet changes with the seasons. In spring, it digs for roots and searches for winter-killed animals. Summer brings berries and insects. Autumn becomes a race to build enough fat for the long winter ahead. Despite their immense strength, grizzlies spend much of their lives simply searching for food. Every season presents a new challenge. Not every predator hunts in packs. Mountain lions move almost invisibly through forests and rocky slopes. Coyotes patrol open meadows. Red foxes leap through deep snow in pursuit of hidden rodents. Most visitors never see these elusive hunters, yet they play an essential role in maintaining Yellowstone's balance. Every predator, large or small, has its place. Life in Yellowstone follows the rhythm of the seasons. As winter approaches, elk migrate to lower elevations. Pronghorn race across open plains. Moose seek shelter in willow-filled valleys. Food becomes scarce. Temperatures plunge. Snow blankets the landscape. Only those perfectly adapted endure until spring returns. Migration is not simply movement. It is survival. Yellowstone's rivers are just as alive as its forests. Native cutthroat trout swim through crystal-clear streams. River otters chase fish with remarkable agility. Ospreys dive from the sky, striking the water with astonishing precision. Even here, the volcanic landscape influences life. Cold mountain streams, snowmelt, and geothermal waters create habitats unlike anywhere else. Winter transforms Yellowstone into one of the harshest environments in North America. Temperatures can fall well below freezing. Snow buries the valleys. Food becomes difficult to find. Yet life continues. Bison use their massive heads to sweep snow aside. Wolves work together to bring down prey. Foxes listen for movement beneath the snow before launching into the air. Every day is a struggle. Every meal is earned. Yellowstone teaches a remarkable lesson. Nothing exists alone. The wolves influence the elk. The elk shape the forests. The forests support birds. The rivers nourish fish. The fish feed bears and eagles. Even the volcanic soil enriches the plants. Every part of Yellowstone is connected. Life has found a way to flourish on one of the most geologically active landscapes on Earth. Yellowstone is often remembered for its geysers, its volcano, its steaming valleys. But perhaps its greatest achievement is proving that life can adapt to extraordinary conditions. Fire created this land. Nature transformed it into a sanctuary. For more than a century, scientists have studied Yellowstone, watching, measuring, listening, not because they expect disaster tomorrow, but because Yellowstone is constantly changing. How do they track a volcano hidden kilometers beneath the earth? How can satellites detect movement smaller than a coin? In the next chapter, we'll go behind the scenes with the scientists who monitor Yellowstone 24 hours a day, revealing the extraordinary technology that helps us understand one of Earth's greatest geological wonders. Yellowstone may appear peaceful. Towering mountains, crystal-clear lakes, steam quietly rising into the morning air. But beneath this breathtaking landscape, an enormous volcanic system is constantly changing. The Earth is always moving. Tiny fractures open and close. Hot water shifts through underground channels. Magma slowly circulates deep below the surface. Scientists know that even the smallest change can reveal what is happening kilometers beneath our feet. That's why Yellowstone is one of the most closely monitored volcanoes on Earth. Every second of every day, someone is watching. The first warning signs rarely come from an eruption. They come as earthquakes, not massive disasters, but tiny tremors that most visitors never feel. Yellowstone experiences hundreds, sometimes thousands, of earthquakes every year. Most are smaller than magnitude 2. Many last only a fraction of a second. Yet each one acts like a heartbeat, giving scientists valuable clues about the movement of magma, water, and shifting rock beneath the surface. To capture these signals, sensitive seismometers are spread across the park. Together, they form an underground listening network. Earthquakes tell only part of the story. Scientists also measure the movement of the ground itself. Across Yellowstone, highly accurate GPS stations continuously track the position of the Earth's surface. They can detect movement smaller than the width of a fingernail. Over months, or even years, entire sections of the park slowly rise, then sink again. This process, known as ground uplift and subsidence, often reflects changes in underground pressure. It's as though the volcano is breathing, slowly, quietly, never stopping. Some of Yellowstone's most important observers aren't on the ground. They are hundreds of kilometers above it, Earth-observing satellites scan the park repeatedly, using advanced radar to detect changes invisible to the human eye, known as NSAR technology. These satellites compare images taken weeks or months apart. Even tiny shifts in elevation become visible. Combined with GPS and earthquake data, scientists can build a remarkably detailed picture of what's happening beneath Yellowstone, without digging a single hole. Yellowstone also speaks through its gases. Steam escaping from vents carries tiny amounts of carbon dioxide, hydrogen sulfide, and sulfur dioxide. Scientists regularly measure these gases because changes in their composition can indicate shifting conditions underground. A sudden increase doesn't automatically mean an eruption is coming, but combined with earthquakes, ground movement, and temperature changes, it becomes another vital piece of the puzzle. Each measurement helps scientists distinguish between normal geothermal activity and signs that deserve close attention. Despite everything scientists have discovered, there is no evidence that Yellowstone is preparing for a super eruption. The earthquakes, ground movement, and geothermal changes seen today all fall within the range of normal activity for this extraordinary volcanic system. That doesn't mean Yellowstone is harmless. It means science is working. Every sensor, every satellite, every measurement provides another layer of understanding. The giant beneath Yellowstone is constantly watched, not because disaster is expected tomorrow, but because knowledge is humanity's greatest defense against surprise. For millions of years, Yellowstone has shaped the landscape of North America. Today, science watches every breath it takes. But one question continues to capture the world's imagination. What would actually happen if Yellowstone erupted tomorrow? Would civilization collapse? Or has Hollywood exaggerated the danger? Thank you for staying through this exciting journey. Kindly subscribe now because our next documentary will be more thrilling.